We're live. It's live now. 1 second. Do you see it? Okay, cool. Hi everyone, welcome to Seed Weekly live stream. I'm Elaine, AR Robotics Team Lead at Seed Studio. I'm so happy today. Today I'm in Palo Alto, sit with Ben and Powell. Ben is the CEO at K-Scale Labs, and Powell is the CTO of K-Scale Labs. I'm super excited to have this live stream together with them to talk about how to build the humanoid robot, leverage K-scale infrastructure and also their machine learning models. So in this live stream, we will detailedly explain and let you can build a humanoid robot right now by yourself. So welcome, Ben and Powell.
Thank you.
Yeah, so K-Scale Labs right now, they are creating an infrastructure to empower anyone can build up their humanoid robots. It's leveraging their, they have the hardware, they have software and infrastructure, and also the end-to-end neural networks to build up this. They have smaller robots and also they have big robots. So together with K-Scale, C Studio and K-Scale, we're bringing the best hackers and engineers to shape the future of the embodied AI that is making the safe, practical, and also accessible for all. So, and I think this partnership aligns perfectly with our mission at C Studio because we're also in a commitment to democratizing the technology and also humanoid to get now is humanoid robot to everyone now. So I'm super excited for this live stream. Ben was at Tesla and Meta for the robots and also autonomous driving. So I'm excited to hear his experience about how to building up K-scale and also humanoid robots. And Power is the visiting lecturer at University Marshall. So I think today will be also a very good lecture time to
We'll
learn,
do our best, yeah.
Yeah, to learn the machine learning back of the K-scale. So yeah, Ben, tell me what is K-scale? What do you do?
Yeah, thanks. So K-Scale is an open source company. Huh? Can you talk closer?
Make it louder. Is there? Press? No, can you come and check? Sorry,
Is it okay?
we need to make it speak louder.
What about right now?
No, press this.
Technical difficulties. We
Switch to the beat, obvious. Yep, just. It's the loudest. Can I see? Louder. Is that very small? No, very small, but some people will hear it. Turn up volume.
maybe we can try the other one.
I think this will
1, 2, 3, 4.
1, 2, 3, 4.
Hello,
Check
hello,
right now.
hello, hello.
Yeah, I think right now is.
1, 2, 3, 4.
I think this one's good.
It's much better.
Yeah.
Okay. Okay, cool. Yeah, so I'm Ben, CEO of K-Scale. We're building. Is it okay?
Yep.
Okay. Yeah, we're making humanoid robots easy. The goal is for anyone who wants to be able to build their own humanoid robot. We want to make the technology for this accessible to anyone. I think this is very important because I think that the future will have lots and lots of robots, and I think they should belong to everyone instead of just to a few people. So specifically, we're focusing on making it possible for people to build robots to run end-to-end neural networks. So before I started K-Scale, I was working as an AI researcher at Facebook robotics foundation models and worked at Tesla on the autopilot, like Elaine said. And I think it's a very exciting time in the AI field to be able to run end-to-end models for robotic control. So we want to make sure that this technology is something everyone can have access to, and yeah, that's our goal.
I think I think Ben, you're really making this mission is coming true. I want to show everyone a video that is Vanshark is building up a kitchen robot in 30 days, leverage kit scale tools. That would be very exciting. Let's see.
Okay, so somebody is going to be chefing it up using this, and then it'll translate to the robot.
Yeah, exactly. And we have the mini robot. That's it's just a scaled version of the big one. This can hang. Yeah. That's a lot of it was printed here. Yeah. So this is going to be used in commercial kitchens. So it's going to be used for chicken tendies and flipping burgers, and all that data goes into a machine learning model, and then it becomes fully automated. Keep cooking. Make robots.
Cool. Good.
Nice. So, Paolo, can you tell me about a little bit about your what is the software behind the KSCale?
Yeah, sure. So when we started the K-Scale, when Ben created the whole project, one of the biggest thing is basically accessibility to a couple of tools that will make you much faster when it comes to building robotics and especially humanoids projects. So if you look at our GitHub, since we are open source, we share not only even the software, but sometimes our Scrums meetings, if you want to join us truly in that building. And we basically try to share everything that is required to build yourself a robot, right? And if you think about it, that starts from the design. So we allow people to take your CAD design and put it into your URDF. From the URDF, you want to work in multiple simulators, for example, to train your models. So we allow to transfer between URDF and any other file, especially like XML that are being used in, I don't know, in simulators like PyBullet or Mujoko. Once you are that, you would like to train some policies, very basic ones like locomotion. So we created some libraries that you can use to put your XML file and train the policy with the simple gate. You're done with that. How about deploying this on the real robot? So I guess that's the biggest effort right now. We are very focusing on right now, and we also sharing this with the community is a chaos system. With Python bindings after yesterday hackathon, also Rust bindings, where you basically, instead of installing Rust and losing hair and 20 hours, whether you have a right Linux distribution, you can just pip install our operating system and start using your whatever locomotion manipulation policy, directly calling the actuators in a simple manner. We also start, with the broader ecosystem. We released an actuator package where we plan to expand the amount of the number of actuator providers. So again, instead of you writing your own stuff, you can quickly look, what we support. Also participate in and adding your version of service or actuators. We would love that contribution, and basically expand that tooling. And once you have that, it's all about for right purpose in terms of getting robots to be useful. At the end of the day, all of this, what we are doing here, doesn't matter if we're not going to have a truly capable models. So we are also trying to share as much of our research and basic models that are in the scale of 500 million to 1 billion parameters, but you can still run, let's say, on the smaller chip, and start using all of these world video language action models. So that's basically the whole stack. I'm sure we're going to go into more detail, but
Yeah, we will go over in more detail later. Thank you, Power. Actually, the robots in front of me, that is Zbot. Actually, it's coming from last year. Oh, actually, the 2 months ago, the hackathon. So the team is the hackathon. They built this robot from zero in 24 hours. And then last week, actually yesterday, we got another hackathon again. People are using this separated team to build their own robot. Their robot applications upon this Zbot. And we also have Olympics, and robot can do boxing. So it's very amazing. Like people can make that in 2 days, and that is leveraging KOS. KOS expose a Python SDK for interacting with robots. You have, as Paul you mentioned, you have complete. You're building the complete the Python library. Right now, it's very good because I saw people can use your the KOS to have robots stand, walk, and also do boxing, dance, and also do the point tracking through the another camera. Yeah. So and also a team do the LLM to control the robots. They build a agent. Yeah. So you're making things very easy, and also as Paul mentioned, but besides they're building tutorials. The getting lower the barrier of the developers building the robot. They are also working very hard on the models and also research. Yeah, so impressive. Ben, can you explain more like for the KOS? What is that? Oh, but before as because we want to play the video for the but we have some issue for the OBS. I want to show everyone the last hackathon how people build up this Zbot. Yes. 会的。Nice. We're back.
Okay. All right. Yeah, I can talk a bit more about what we're building here. Can people see my screen? Or?
Yeah.
Okay, there we go. All right, there we go. Okay, yeah, I'll just give a quick overview of what our company's built and what we are excited about sharing with the open source community. So all of this is available on our website, docs.kscale.dev. We have a operating system for controlling humanoid robots. So this is a bit different from ROS because we want to just make it basically all of the drivers for the cameras and microphones and IMU and stuff are all just built into the operating system. So you just install it and it works. You don't have to mess around with a long installation process. And then the interface for it is through Python SDK that we talk over a gRPC HTTP server from the OS. It lets the OS be in real time without.
Wait, we're not share the screen.
Oh.
Oh, wow.
All right. There we go. One day we'll learn how to use computers, but slowly. Yeah, so this is our documentation page with the OS and then a bit about like kind of the other parts of the K-Scale platform. We have built a few tools for getting ML models to run well and some tools for simulation. So if you want to train a RL policy in simulation, you should be able to do that. Some other tools for miscellaneous stuff. We also have a guide on what are the hardware that we prefer to use. You can actually look up the bill of materials for our own robot. For the actuators, for our larger one, we're using Robstride. They're a great actuator company out of Beijing that has been super responsive for us. On the carrier board for the Jetson, we're using the Seed Studio J501, as well as the Respeaker microphone array and a handful of other sensors from that we felt were appropriate. This is a diagram of where those sensors are on the robot. So if you want to go look that up, very happy to. But I would actually like to show a quick live demo, and I apologize if this is slow or if this doesn't work super well. But I'll give you a quick live demo about how you can make your own robot. So I have my fresh Onshape file here. We can just start by making a really simple. Really simple. Let's say like. Let's just say like a very simple extrusion. Let's say like that guy, and then we'll say leg, and we can go ahead and make another one for body. This is something you would spend a lot more time on, but I'm just going to give a quick overview of how you can get a CAD model to train an RL policy. Let's do like a really simple robot. We'll just do the legs and the body. We want to define, in order to simulate it well, you have to define the weight of the objects and the density. So let's just say we're going to make this out of ABS plastic. Go ahead and assign material here. And then, that's not what we want. And then we can go into our assembly and just make like, the body and two legs. We'll define revolute mates between the body and the legs. So make a little revolute mate there, make a little revolute mate there. And then the last thing is we want to make sure that we have limits on this guy. So I say minus 90 to 90 and minus 90 to 90. This is a very simple robot. It's not the best robot. I guess if we were to try to make it walk, we might have some issues. But for the purposes of this, we can kind of show what we can do. So first thing is you want to share your model with, basically you want to share it so anyone can access it. So this turns on link sharing. Next is you can take this link and go over to dashboard.kscale.dev. Actually, if you go to kscale.dev, if you go to our website, it is this link in the upper right corner. You can go log in and it takes you here. This is a little bit rougher page, but we can go to Robot Hub, click Create, and we'll just make a new robot called Seed Robot. And then we'll just click Share Robots. And then down here, you can click Add Onshape URL, put the URL from the Onshape model and hit Save. And I hope this works because this would be embarrassing otherwise. You can click Sync, and it'll start to pull the CAD model for that Onshape and generate the URDF. So the URDF is now available here. You can go to this file viewer and hit URDF, and it'll visualize this. URDF. So we built this pipeline actually entirely open source. So you can just go to github.com/kscalelabs/onshape to view the source code for it. There's no mystery. We just wanted to run it in the website so that people can share the assemblies more easily. And then if you want to download the URDF, you can hit download files or view listing. So that's a very fast introduction to how you can make your own robot design and make the simulation artifact. The next step is going to be taking that URDF that you've generated and training a policy to make it walk. So you can go to kscalelabs/sim and look at some of our examples. We have, for example, in the getting started, some pre-trained walking policies. If you go to sim/resources, you can see some of the other robots that the sim library has. So for example, the Unitree G1 or GPR, which is our own full-size humanoid that you can, oh, maybe that link's not working. So yeah, the training, the policy is pretty well documented. You want to use a NVIDIA GPU. We use a 4090 for our training purposes. But you can see the training scripts, everything you would need to get started training a policy. So once you've trained a policy, then you can go to kscalelabs/KOS. And this is our general purpose operating system for running the policy in the robot. So for the robot that we have sitting on the desk here, we have implemented the RL walking in the real robot and done the sim to real. So this lets you go from basically an idea to a CAD model to a URDF to a policy and finally to a walking robot, which is pretty cool. So yeah.
That's very nice. Yeah, so then as we're, yeah, okay, I need to make sure I speak louder. So it's okay right now. Okay, I will speak louder. Yeah, so yeah, talking about, so you get tools by making very accessible. So because your mission to making like everyone is the platform, the everything of the humanoid robot is accessible to the developers, or I mean in the future, and customers, users. Yeah, so I want to address some challenges right now for building up the humanoid robot. I mean, so humanoid robot is so popular, it's a hype right now. So, but it's not accessible, literally not accessible for everyone can build that. So there are several challenges like hardware and software, and also research. So for the hardware, I don't think everyone can build their own Unitree G1. So Unitree is super cost effective, I know, but it's not everyone can pay for that or building from zero. I mean, the mechanical design, gather all the hardwares. Yeah, so access to a very easy to use hardware. I mean, a lot of easy to use hardware package, and also get all hardwares and making hardware compatible with each other. That is a very biggest challenge, right?
Yeah.
Yeah. So how you start? How did you getting through this challenge?
Use this microphone. Okay. Yeah. So, before I was working on Kscale, I was working as a robotics researcher at Facebook, and the bane of my existence was how difficult it was to just get started making a robot do something cool. A lot of the time, projects that were supposed to be open source were actually difficult. They didn't have good documentation. It's very difficult to work with. I developed a somewhat severe loathing for ROS because it was so hard to install ROS. Takes 2 days just to get everything set up before you can finally just start making the robot do something cool. So we wanted to, at Kscale, focus on building robots that have great documentation, are truly open source, optimized for running neural networks.
我要更换电池，这没有电了。
Uh-oh. Oh, it's back.
Coming back.
Wow.
Okay.
Computers, man, it's so hard. Okay. Yeah. So
Where we were.
where were we?
Right.
Talking about how much I hate Ross. Okay, I mean I can go on about how much I hate Ross for a long time, but that's not what this is about. We're about talking about making it really easy to use robots. So basically, I felt that with humanoid robots, because the control loop for actually doing locomotion with the RL policy is very tight, we wanted to basically just focus on building a small, fast, compact operating system to run this model. That way, you can focus on building just a very robust software interface for a neural network. On the other side, we want to make the hardware as cheap, useful, and affordable as possible. So we have robots like the Zeroth O2 that are great platforms for KOS, and we're going to release an upcoming larger robot that will also be, I think, very suitable for KOS. But the other part is that if you want to build your own or you want to make modifications, you can do that. So you can use the highest quality materials that you want, choose your own suppliers. The goal really is to make this as democratized as possible, because I think that's the right way to make it useful and accessible for everyone. Yeah. So yeah.
So for the cable you mentioned, so there is a high, the bigger one, you're using the AGX Orange with
that's right.
the J501 carrier board, right?
Yeah.
So yeah, so I wonder why you choose this board, and what are all the interfaces you're leveraging right now? Because there are so many interfaces here. So this is a 501, the carrier board, the bearer board. Jenny, can you hear me zoom? And then I want to show this board. Okay, we got, okay. Yeah, so this is the carrier board for AGX Orange we already released. And so it's called Reservo J501. We designed this for generative AI and also robotics, because it's using AGX Orange, so it can deliver up to 275 TOPS AI performance. And so what is more, it's very good to use for both production and also the development. So you can, for your robot, it has, so first, it has a couple of, it has 3 USBs. But I think right now we may, in the next version, we'll bring more USBs. And we have the DID for the CAN, and also IS232. And also we have 2 Ethernet, and one is 10 gig. And also we have this one. So we have another adapter of the GMSL boards. This is adapter boards. K-Scale right now is also using the GMSL camera for their robots. And on the back we have mini PCIe for 5G, 4G, 5G, and also SSD. So yeah, that's all the interfaces for this board. What else? We have some USB Type-C for debugging. So yeah, that's all for so that's all for this board. Now here is attaching AGX Orange Jetson module. Yeah. So Ben, tell me about how you leverage this board, because this is board only is for this is for the heart of the robots, but what's the preference you're connecting with? then
Yeah,
we
sure.
can come back.
Yeah, I can talk about how we ended up with Seed. Actually, we were exploring. You know, like I think a lot of other U.S. Startups, we try to find really good carrier boards for the edge devices, like the NVIDIA AGX. We actually made our own carrier board for the Jetson Nano. But when I met with Seed in July, I was just looking for a board that would work reliably and robustly. So we ended up going with the J501 board because it's has all of the like peripherals that we need. We are using CAN to communicate with motors. We're using like GMSL cameras. It all kind of just comes packaged with the board, so we could focus on basically just building, the operating system and the software rather than having to mess around with a bunch of drivers and yeah, like the CAN is like isolated ground, like it's all done correctly, and so we can just focus on just making the robot work. So.
Maybe I will add a little bit. So, like, if you think about typical build up for let's say model that you want to work on top of the that board, is like we're thinking about long term vision, and we know that at the end of the road there's going to be one model that will take audio, will take video, will take proprioception from the robot. So if you take this assumption, right, then when you start building up the whole thing, the board needs to provide all of this. We had a lot of testing, a lot of design. Then J501 came in, and if you think about like design choices for cameras, typically everyone start from USB. Here we have natively GSML. You can multiplex them, so you have a couple of them. GSML reduce the latency while giving better high resolution. So if you think about training your models, you have better quality vision at the highest rate. Then if you think about conversational aspects, like the robot should be able to talk to you and understand your when you're talking just in natural language, right? With the more and more powerful models, I think that's going to be like an obvious thing. The way we're going to interact with the robots, no terminals, just talking to each other. So, if you think about speech understanding or text generation into speech, there's again a lot of things you have to consider. Here on top of the J501 board, Seed is producing re speakers. So there's a lot of pain getting the right microphone, getting the right drivers, and then for really production systems, you need mic arrays to really distribute the noise, especially if there's many people in one room and you're talking to your robot. So basically, Respeaker put on J501, works off the shelf, gets the right setup so that your speech understanding models work off the shelf. So like reduce quite a lot of our hours of setting things correctly, and at the good price, which is also important because we were trying to make it as much affordable as possible. Finally, with GPIOs, like there's hundreds of CAN adapters, people working with different ones, having like direct access to it, without even soldering is like saving a couple of minutes every now and then. So just overall, the board was really helpful thing for us at some point, and I think accelerate quite a bit the progress we made.
Yeah, thank you, Power. Yeah, I want to continue on that you say that a neural network to control, to communicate and control everything. Not only, all the joints of the models and IMUs, microphone, and also camera, right? Yeah. So because previously we also tried OpenVLA, but models like OpenVLA is we use like 8B parameters, and that is more, it's kind of constrained to deploy in the edge devices.
Yeah.
So yeah, how you address that challenge?
Yeah. As I said, we share everything we do. So we also share our research journey. Maybe I can show the one of our
Yeah.
model that we open sourced.
So let's share the screen first.
Yeah.
Wait.
So if you want to see our first attempts, basically to bring back these big models into the device and running on AGX on the robot, we know, as I said before, is that large language models, vision large language models, will be the future of robotics. And at the same time, we also know that as the model scales, it's almost impossible to run them on device at the speed that we need. And the reason we need that speed is that when you add locomotion and manipulation together, you're constantly trying to balance the robot. And also, while interacting with the environment, environment might be pushing you, might be have like uneven terrain. So you have to quickly adapt. That means that we have to make decision almost 10 to 20 milliseconds each time to quickly adapt, even though if we might be even doing a very boring, slow task like folding the laundry. Our one of the holy grails is to basically reuse the pre-trained large VLA models or train our own that has a huge capabilities, but at the same time are small. So there is always a trade-off, and that release, what we are showing is that we are reusing large models like Llama to with some pre-trained vision encoders, but we make them generate predictions about what to do next as a robot and what the setup of the joints, not in autoregressive manner, so that can get us the boost. There is a lot of research happening right now to make things faster, to use diffusion models, and I think as a community, we are getting to the place where we will be able to do it at very large models, starting from 1 billion parameters. We don't still see like a lot of this being open sourced. So we're trying to make it more accessible because I think, thanks to that, there's going to be more data, more people running these models and accelerating the general progress.
Yeah, I think we talked about this.
Yeah. Talk about this. Yeah.
Yeah, we talked about this. The sensors on board.
Yeah.
Yeah. Sorry, I was a little. We had planned this as sort of
Yeah.
order of operations here. Got a little turned around.
Yeah.
Cool. Yeah.
I mean, this already gone. We already worked through already, right?
Yeah.
Okay.
Yeah.
Cool. Yeah. So I want to know, like, yeah. So I saw you're gonna have the hackathon again. You're gonna have the hackathon again next month, right?
Yeah. Our goal really is to make it possible for
Mm.
anyone to get started super easily
Mm.
building robots. We host hackathons in the Bay Area. If you want to come by, if you're in the area, if you want to participate remotely, also very happy to help. Anyone that's really interested in just like making their own robot, would love to talk to you and figure out how we can help with that. Yeah.
Yeah, if you have great ideas about robots, or you're building your robots, and you have your own robots, please bring to their hackathon next month in the Bay Area. And so in their garage, they have everything for building up the robots. So they have
Yeah.
bots. They have you can have a sneak peek of their humanoid robots. They also have other humanoid robots, like you can see Unitree G1.
Yeah.
Yeah.
We have a lot of humanoid
Yeah.
robots
And
in
they
our
get
house.
a lot 3D printers, all the tools, models, servos. Yeah, so check it, and they're gonna send a event page later, so don't miss it out. And yeah, and also for this live stream, we're going to we're giving away one Orange Nano dev kit. yeah, so I want to make sure everyone is here. So, okay. So, we're gonna have a raffle. So Jenny, how can we get? 我们是怎么去抽那个
Or can we get the screenshot of the chat box?
Yeah, yeah.
So just
Yeah.
pick one to
Okay.
round up the numbers.
Okay. So so everyone so we are giving away the Ori Nano dev kit now at live stream. So everyone yes, you can type robot. Everyone type robot, and then we're gonna give a screenshot in 3 seconds. Okay, so let me go into the live stream first. That is very good Christmas gift. Merry Christmas. And so I'm going to. Okay, so we're starting now. So make sure you type robot in the chatting, and we will screenshot we'll screenshot for the number 3. So the people in the line 3, and to get the Orange Nano dev kit, and make sure you're gonna use that with K-Scale platform. Okay, so okay, 3, 2, 1. Okay, I got Milan Dahil. Milan Dahil. You got the Orange Nano. Okay.
That's right.
Congratulations, Milan. I look forward to your feedback. Okay, wonderful.
Shall we answer the questions in the chat?
Yes, of course. So yeah. So yeah, it's coming to our last yeah. So we're gonna
Q&A,
yeah Q&A. We will leave some time for Q&A.
Since
Yeah,
we
I
got
think-
a lot of spam for the robot, I think
Yeah.
if anyone has any questions, you can feel free to use the chat again
Yeah.
to post them. We are very happy to answer all of them.
Yes, but before we got the questions, so Ben, how can we get started now? Besides hackathon, how can we get started with Kidscale now?
Yeah, I think if you have a 3D printer and some servos, you can just try making your own robot. We have the instructions for the 0th02 robot online. I think the total BOM is about $350. The other robot that I think is cool that I built before K-Scale is called the Spot Micro. I really recommend that one. Yeah, I think it's we want to make sure that like there's a good community, so you can join our Discord, talk about your own robot builds, figure out, ask questions from other people that are building robots as well. Yeah, or just shoot me an email. I'm very happy to talk about robots too.
That's great. And so I see some people are discussing some questions. So it said are you sharing CAD files for 2 robots in front of us?
Yeah, maybe I can show where those CAD files live. Maybe. So you can go to go to 0th .dev, I think, or no, 0th.bot. This page. You go 0th.bot. This is the project page for the 0th01 robot. You go to docs here, and it shows you the full bill of materials for this robot, the 3D printing guide, step-by-step assembly, software setup. So this is fully open source. The software for running this, you can go look at it. It's on it's a Python library and API. That's one way to that's how to get started with this one. Our website, kscale.dev. You can go here and oh man, our images do not load very fast, but you can see our docs as well, our dashboard. And this is how you can go through that flow that I showed earlier on getting the model into simulation. So, which I should probably delete this. Yeah, and then we have the docs for the hardware setup that we use for our own robot if you want to build your own.
Yeah. Cool. And another question. So we got, uh, what is the range of the hardware? Is that only AGX or?
No, we want to make robots for all sorts of hardware. So we like the AGX Orin because it's a really powerful computer. It's suitable for running larger 8 billion parameter models in real time. But we also have a bunch of we've experimented with the Jetson NX, the Orin Nano, even Qualcomm boards. If you hate yourself, you can try a Qualcomm board. So yeah, like the goal for us is really to try to support any kind of hardware that people want to use. Like the goal is to make useful robots. So
Yeah.
we want you to just, if you design your own robot, we can figure out how to make it do something cool.
Yeah. And also for Zbot, the in front of us, so that is for the camera wise, it can also support the ray camera. So we're bring that is very soon. Yeah, so ray camera can be the main controller, but with the sensor as the eyes, and
Oh.
also use the ray speak, and use the ray speaker.
Yeah, let me just go quickly to the zeroth bot page. I think I'm sharing it.
Yeah, sure.
If you go to zeroth bot, you can see the when we first built this, it just uses a Milk V board from. It's a simple RISC board. We were kind of like putting this all together ourselves. The camera and the LCD panel and stuff like these are kind of sourced. The nice thing about the Recamera is actually has like kind of all of this stuff built into a same package with a slightly more powerful RISC chip on it. So yeah, I mean, I would be very excited to help with someone building a robot around the Recamera.
Yeah. That's great. And next question to Power. Any task model?
Task model.
Yeah.
I'm not sure whether I understand the question. If I would, yeah.
I guess they're asking about like for doing the task, like let it
Yeah.
dance or
Yeah.
work or
Yeah.
turn around.
Yeah. For sure.
What is that model?
Yes.
based?
Yeah. So the current models do not offer off-the-shelf capabilities like that. However, the way we want to build the whole thing is that, as I said, the model always takes either speech or language input and transfer this into text that is embedded into the model, and then the model will understand. So most of the tricks that the robot will now understand is like walk forward, like go to the next room, turn left, or fold the laundry when it comes to manipulation tasks. So we try and do everything so that you could, tally up, for example, your robot and train the new trick. We had at the hackathon, like in 48 hours, teams who were recording themselves through key point detection to make the robot copy that. You can save these motions through yet another library that we provide you called KREX. Once you have that, you can fine tune the model to basically learn that when you're saying dance like Ben, it will start doing some breakdance, for example. But that's something that you will have to work on your own right now. The models are not that smart yet.
Yeah. Okay, great. It's very good live stream. So yeah, so to getting started with K-Scale, building up a big robot, middle robot, or small robots. So everything is open source. Software and hardware you can get from Seed, and you can check all the BOM list on their website. So yeah, that's it. So oh, by the way, we have Christmas sale on cstudio.com right now. We're working through a 2 weeks Christmas sale. You can just directly go to the website and click on the homepage. We get very big sale right now. So make sure you bring your Christmas gift for happy hacking. Yeah. So
If your
thank-
relatives are nerds, if your relatives are nerds, this is good. Good
They
Christmas
are.
gifts. Okay, good.
Yeah, we are. Yes.
Yeah.
Okay. Great. So thank you, Ben. Thank you, Paul. And I'm looking forward to the next hackathon. And we're gonna post a lot of things, blogs, and also keep updated their hackathon and K-Scale on our newsletter and YouTube videos. Yeah, and glad to we can hack with everyone to build up human or robot.
Yeah.
Okay.
All right. Thank you.